Hello.
Hello, ma'am.
Hi, good. But there are some new people I can see. Deepak,
Yes, ma'am.
Devanand. Please switch on your camera. Let me see you. Deepak. Hi, Deepak.
Hello, ma'am.
Can you switch on your camera so that I can say hello to you? Otherwise, I am saying hello to the wall. Please switch
One
on.
second, ma'am. 1 second.
Yeah. Adok. Adok Shajan. Adok Shajan, please open your switch on your camera so that I can say hi to you. I can't
Hello,
share
ma'am.
my screen. Hello. Hello. Mr. Raghav, I'm so sorry to bother you, but my that share my share screen has okay now somebody has enabled. So sorry. Oh, okay, okay, thank you. So, sorry for the delay in starting because the host had disabled my screen sharing, so I couldn't start. Now, today we are a good number of children present. I am very happy that so many of you are present and you all came in time. I would like to, talk to the new students first. Deepak, you have joined now, so will you be able to manage the topics which I have already finished on your own? Deepak?
Yes, ma'am. I'll manage. I will see the old videos soon.
Yes. And so, Adok Shajan, tell me what about you? Will you be able to
Yeah,
manage
yes, ma'am.
the top? Yeah, so please go through the topics which I have already taught you. And in case you need some special help, then two of you and one more person who had joined a little later, I can take one or two extra classes for you all. You can discuss with the representative in the learning room. Okay, so all those who want an extra class, they can do that. So we have just finished aldehydes and ketones in the last class. Most of the reactions of aldehydes and ketones we finished. Now today we are going to do a few reactions, especially of benzaldehyde. Okay, so we are going to learn about benzaldehyde. Now, all those who can switch on your camera for a while, please do that, because I should know who all are there and what you are doing. At least when you say good evening, you should switch on your camera and say that. It is my sincere request to all of you. Okay. So when the class begins, I think that much courtesy you should have to switch on the camera and say, good morning, ma'am. Shouldn't you? So so Vaishnavi, how are you? Sai, how are you? Sanjay, how are you? Ashwin, how are you? Hariharan, how are you? Good, good, good. Okay. So these are, basic things, when I teach, I feel more connected if you all switch on your camera. It is not easy, I know, but if you can without any, see, if you say, ma'am, I have a problem, I understand, but if you are genuinely having a problem, it is good. No problem. I do understand. But if you can, I can only request you, it will be good for me. That is a little favor I am asking from you. Okay, so please do that. So so far we talked about aldehydes and ketones, which were aliphatic. Aliphatic means they were having a simple carbon chain. They were obtained from aliphatic compounds. Now benzaldehyde is a little different. Why? Because here CHO group is attached to the benzene ring. So we are going to talk of this compound called benzaldehyde. So it is CHO group now is attached to the benzene ring. So we are going to learn a few reactions of benzaldehyde. First, a few special methods for preparation of benzaldehyde. Now, for preparation of benzaldehyde, there is one very interesting method that we use, and that method is from toluene. What is toluene? Anyone who can tell me what toluene is? Chitra, you know what is
C6H5CH3, ma'am.
C6H5CH3. On the benzene ring, you have a CH3. This method is known as Itard's reaction. Itard's reaction. Right? Now, in this reaction, you have to understand, if I take toluene and I do oxidation of toluene, any carbon side chain, if I do oxidation and I take alkaline KMNO4. Any carbon side chain will quickly change into benzoic acid, COOH, benzoic acid. This is a normal reaction. Any carbon side chain, if I have any carbon chain, irrespective of what the chain is, it could be CH3 or C2H5. When I oxidize it, I will only get what? Benzoic acid. But I don't want benzoic acid. I want benzaldehyde. So how can I oxidize toluene but to only benzaldehyde and not to benzoic acid? So what we do is we take toluene and we do oxidation. We do oxidation. This is an easy way of writing the reaction. You can write 2O, and you can also write the oxidizing agent is chromyl chloride, CrO2Cl2. Now this oxidizing agent, it oxidizes toluene to benzaldehyde, CHO, removing 2 hydrogens and H2. So this is a short method of writing the reaction. However, the reaction is a little more complex than this reaction. I will explain the reaction to you. So in order to understand the reaction, why we use this oxidizing agent is what we are trying to understand. We need to use chromyl chloride. Why? And how does chromyl chloride help us in making benzaldehyde? So what we do is we first react toluene with chromyl chloride. Toluene reacts with CH3. This is somewhat the mechanism. It reacts with CrO2Cl2. In presence of a non-polar solvent, you can take carbon tetrachloride or carbon disulfide. And then it forms a addition product like this, CH, and this is twice. So you get CH, OCRO, OCRO, HCl2. Okay, OCRO, HCl2 whole twice. So it is just an addition product. Okay, one H from here goes into OCRO, HCl. So you get this Cl2 whole twice. This is a complex. So what I'm trying to say is, if you are not able to write the structure of this complex, it's okay. You can write this on the arrow. Then what is the next step? It is hydrolyzed with water, H2O and H plus. This whole thing breaks out and you get benzaldehyde. Okay. So what is the role of this chromyl chloride? It forms the complex. It forms a complex. What is the advantage of forming a complex? It forms a complex. What is the advantage of the complex? It prevents the further oxidation of benzaldehyde to benzoic acid. So this is known as Itard's reaction. Okay, so using Itard's reaction also we can prepare benzaldehyde from toluene. The second reaction here is reaction of toluene again, but this time you are doing chlorination of toluene, chlorination in presence of sunlight. So when you do chlorine in presence of sunlight, what type of reaction takes place? It is a substitution which happens at the side chain. So what will you get? You will get here CHCl2, 2 chlorines. The hydrogen is substituted, 2 hydrogens are substituted with Cl2. And then you reacted with water or with aqueous KOH. Aqueous KOH. What does aqueous KOH do? It replaces the Cl2 with OH. So what will you get? CH, here OH and here OH. 2 OH on the same carbon is not stable. So what will you get? CHO, benzaldehyde. So these are slightly difficult reactions of preparation of benzaldehyde. The third one also, it is known as Gatterman-Koch reaction. Gatterman-Koch reaction. So what is Gatterman-Koch reaction? Please try to understand that also. So you have a benzene ring, and on the benzene ring, you react it with carbon monoxide and HCl, right? And in presence of AlCl3, on the benzene ring, you get CHO. Okay, so you get a CHO on the benzene ring, CH and O, sorry. Carbon monoxide and H, they form CHO like electrophile, and that electrophile goes and attaches to this. So CHO, and I'll write HCl again. HCl acts like a, it is important reactant. It is regenerated at the end of the reaction. So you get benzaldehyde also by Gatterman-Koch. So here, these are slightly difficult reactions. Here, the important one is Icard's reaction, which you learn to write in a simple way. Don't learn the complicated way of writing this reaction. The properties of benzaldehyde, if I take benzaldehyde, the physical property, it is a liquid, and it is a liquid with a smell of bitter almonds. You know what almonds are? Okay. So bitter almonds. This is a solvent in floor polishes. So if you go to a house, which is a new house where the floor has been recently polished, you'll get this typical smell, and this is a smell of bitter almond. That is how you recognize benzaldehyde. All properties of benzaldehyde are like any other aldehyde. The properties which are different for benzaldehyde, I'll talk only about those. So first is the properties of benzaldehyde, the reactions due to benzene ring. Reactions due to benzene ring. So I have told you, now we have done so many compounds which contain benzene ring. Who will tell me which are the 4 important reactions of the benzene ring? Tell me. Can you tell me which are the 4 important reactions?
Ma'am, sulfonation, nitration, halogenation, and
Acylation, ma'am.
What do you
alkylation.
call that reaction? Alkylation and acylation. What is the name of that reaction?
Friedel-Crafts, ma'am.
Yes, Friedel-Crafts reaction. So it is known as the Friedel-Crafts reaction. Okay, so these are the 4 reactions due to benzene ring. What is that we use for bromination? Supposing I am doing, I will take Br2 and FeBr3. FeBr3. If I do chlorination, I will use aluminium, AlCl3 and chlorine. For nitration, concentrated HNO3 and H2SO4. For sulfonation, concentrated H2SO4, and for Friedel-Crafts reaction, we can use, say, CH3Cl and AlCl3, or CH3COCl and AlCl3. Now we have to see how this works for benzaldehyde. So let us write here. This is my benzaldehyde, CHO. And I'm going to write the 3 reactions. Now, first, I should know what is the effect of CHO on the benzene ring. It is meta-directing. Why it is meta-directing? Due to and deactivating. Deactivating and meta-directing due to -M effect. So where will the new substituent come? You will know. So this is CHO, and I have taken Br2 and FeBr3. Where will Br come on the benzene ring? On the meta position. If I do nitration with concentrated H2SO, HNO3 and H2SO4, what will I get? Meta-nitrobenzaldehyde, right? And if I do sulfonation with concentrated H2SO4, I will get meta-SO3H, okay, meta-carboxy benzene, meta-carbal benzene sulfonic acid. I think this reaction is not in your syllabus. Let me check. Only nitration is there, so this we have not learned. So we don't have to bother about sulfonation. And the important thing here is benzaldehyde does not show Friedel-Crafts reaction, does not show alkylation and acetylation. Okay, so what you have to remember is that if a group is meta-directing, then it will deactivate the benzene ring. And if the benzene ring is deactivated, then Friedel-Crafts reaction will not be shown by that compound. Friedel-Crafts reaction will not be shown by that compound. So that is how these are the important reactions, extra reactions of benzaldehyde. All other reactions are like any other reaction of any other aldehyde. So we are done with aldehydes and ketones. Now we will start with carboxylic acids. Today we are going to mainly start with carboxylic acids. By the way, how was your test last week? Vaishnavi, Sanjay, how was your test?
It was moderate.
Easy only, ma'am.
You got 40. Oh, you got your marks. I
No,
did
ma'am.
not get.
No, ma'am. It was moderate.
It was moderate. Okay, okay. What about you, Sanjay? How was your test?
Some part was easy, ma'am, but some were tricky, ma'am.
And Sai Kalyan, Hariharan, how was it?
Moderate, ma'am.
Okay, let me see. I have not got your marks, so I don't know. I have not seen the question paper also. I'll ask for the question paper.
Yes, the test was
Okay.
easy and yes.
Okay, great. Now, today we are going to learn about carboxylic acids. We learn them along with aldehydes and ketones because carboxylic acids also contain a carbonyl group. But which is a carboxylic acid which contains CO carbonyl along with the hydroxyl. So it has a C double bond O and a OH, both of them. And this is known as the carboxyl group. Okay, carboxyl group. So this is a carbonyl group, this is a hydroxyl group. The combination of two is known as a carboxyl group. So we are going to mainly learn about those which have only one carboxylic group. If the acid has one carboxylic group, we call it monocarboxylic acid. Monocarboxylic acid is which one? Which has only one COOH group. What is the general formula for carboxylic acids? It is CnH2n and O2. CnH2n O2. So let us learn the names of few carboxylic acids. So suppose first one, which has only one carbon atom, it is HC double bond O and OH, right? You can write it as HCOOH. And only one carbon atom, so it is methanoic acid. And importantly, the common name of this one is formic acid. Formic acid. This is the acid which is present in the ant bite. When ants bite, then this is the acid they inject in your skin. That is why you feel the pain. So that is formic acid. The second one is two carbon atoms, so CH3, C double bond O and OH. So I can write it as CH3, COOH. This I think all of you know. This is ethanoic acid. Ethanoic acid, and this is commonly known as acetic acid. And this is present in vinegar. I hope you know what vinegar is. All Chinese food, they make use of this vinegar. So vinegar is an important ingredient of Chinese food. The third one that we should learn now with three carbon atoms. So CH3, CH2, COOH. So what will I call it? Propanoic acid. So up to two carbon atoms, we should know the common names. Now we can just learn the IUPAC names. So propanoic acid. Now I can give you names of a few acids which have two COH groups. You should know the nomenclature. Supposing there are two COOH groups, right? So what will I call this? This is two carbon atoms. So ethane dioic acid. And the common name of this acid is oxalic acid. You should understand the name of this acid because this is the acid that you use in titration. Oxalic acid. Let us see if there are, there is COOH, CH2, COOH. How will I name this? 1, 2, 3 carbon atoms. So it will be propane dioic acid. Propane dioic acid. So if there are three, this is the sixth one, you should understand if there are three COH in the group, in the carbon chain. So let me write 1, 2, 3 carbon atoms, and on each carbon atom, I put a COOH. So CH, COOH, and CH2, COOH. What will I name this acid? So now the problem is there are three COH. So I cannot, if I include the first and the last in the longest chain, I'm left with the middle one. So when you have more than two COH, then you don't count any COH in the longest chain, like we did for aldehyde, same way. So what is the chain now remaining? Propane. And on each carbon atom, I have a carboxylic group. So I cannot say 1, 2, 3 oic acid. I have to say that I haven't included the COH. So what will I call it? Propane 1, 2, 3 tricarboxylic acid. So when I say carboxylic acid in my IUPAC name, I mean that I have not included the COH, which is the part of the functional group, in my longest chain. So propane 1, 2, 3 tricarboxylic acid. Okay. Now, so with this, if I write a benzene ring and I put COOH here, I can call it benzoic acid. Benzoic acid. I can also call it benzene carboxylic acid. Benzene carboxylic acid. That means benzene is there, on that there is a COOH group. So if I have two COOH groups on the benzene ring, right? What will I call it? I will call it benzene 1, 2 dicarboxylic acid. Dicarboxylic acid. All right. So you should understand if this is not included in the longest chain, then you have to write the suffix carboxylic acid. Okay, so especially when it is a cyclic compound, you will call it a carboxylic acid. Now this has a common name also. It is called phthalic acid. P is silent, so we call it a phthalic acid, COH on the adjacent carbon atoms. We are going to use this acid in many compounds. Now we don't have polymerization in our syllabus. When we were using polymerization, this was a compound which was used in making a very important polymer, which is used for making PET bottles. You have seen those plastic bottles, which are transparent plastic bottles made of this polymer called PET bottles. Okay, so that is made from phthalic acid. Okay, so this is about a little bit of nomenclature. Let me give you one or two names which children generally make a mistake. So supposing this is my COOH and here CH3, CH2, CH3. Who will tell me the name of this acid? Somebody tell me the name of this acid.
Ma'am, butane 2-oic acid.
Butane?
Ma'am, butane 2-oic acid.
Butane 2-oic acid. Is somebody having any difference of opinion? Is it correct name? Sai Kalyan, is it correct name? All of you agree? Sanjay, is it the correct name?
Yes, Miss, correct name.
No. Butane 2-oic acid, why you are saying? Because you are thinking that this is my longest chain. This one is my longest chain. All right. But that is not true, because my longest chain should include the functional group. So what is my longest chain? My longest chain is not this one. My longest chain is this one. Right? So it is definitely butanoic acid. But what is the correct name of this one? This is the name where most children make a mistake. So what is the correct name? 2-methyl butanoic acid. Butanoic acid. Okay, so when you are naming an aldehyde or an acid, please remember the carbon which is a part of the functional group should be a part of the longest chain. Okay, even if that chain is not the longest one, but you should make sure that the carbon which is a part of the functional group is a part of my longest chain. So this is a problem that you face when you are naming those compounds where the functional group contains carbon atom. Especially when you are naming acids or aldehydes, please include it. All right. Now this next one, what will be the name? Anyone? What will be the name? Now here there is a problem. Tell me.
Is it 2-phenyl propanoic acid?
Yes, 2-phenyl, not 2-phenyl. Why should it be 2? This is 1, 2, and 3, third carbon atom, isn't it? Don't forget this here. So it is 3-phenyl. Did you understand? 3-phenyl propanoic acid. Very good. 3-phenyl propanoic acid. Now, if I take this one, CH3, CH3, double bond, CH, what will be the name? Who will tell me? Anybody, please. Those who are new, please, do you want to attempt? Deepak, do you want to attempt? Deepak, Devanand, do you want to
Yes,
attempt?
ma'am.
Try.
Sure. 3-methyl.
Yes, very good. 3-methyl. How
Propanoic
many
acid.
carbon atoms? 1, 2, 3, 4.
Butanoic
So
acid.
correct. Now, but you have to take care of the double bond also. So where is the double bond? But-2-enoic acid. Right,
Yes,
Deepak, what you have to do is you have to first find the number of carbon atoms in the longest chain. That is correctly you pointed out, that is but. Right, now the secondary suffix is -ene. Why? Because after the second carbon atom there is a double bond, so I should write 2-ene. And the secondary suffix is oic acid, so 3-methyl but-2-enoic acid. Did you understand, Deepak? So you have to, sometimes if there is a double bond, you have to take care of the double bond also.
yes, ma'am.
Okay, okay. Now supposing it is a cyclic compound, let us name a few, because there is always a name for which you may get to write the IUPAC name. You should not miss out on this. Here there is a NO2, here there is a COH, here there is a NO2, and here there is a NO. So what will I call this one? Somebody? So this is definitely benzoic acid. On benzoic acid, what do I have? Or this is carbon atom 1, 2, 3, 4, 5, 6. So what will I call it? 2,4,6 trinitrobenzoic acid. Did you understand? 2,4,6 trinitrobenzoic acid. There is one more, just one more, which I will ask you, because this is one which is asked sometimes in conversions. What is the name of this one? Now, Sanjay, you haven't answered. Tell me. What is the name of this one? How many carbon atoms in the longest chain, Sanjay?
3.
So what will I call it? Propanoic acid. Right? On the second carbon atom, I have a branch. What is a branch? OH. So if the OH is a prefix, what will I call it? 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. Now, this has a common name. It is called lactic acid. Lactic acid is present in what? In milk. When the milk becomes sour, then the acid which is present in sour milk or in curd which has become sour, it is lactic acid. So now all these carboxylic acids, they are weak acids. First of all, they are weak acids. What is the meaning of weak acids? They are not like sulfuric acid, nitric acid, and all, which are strong acids. Strong acids are completely ionized in solutions. Organic acids are weak acids, which are not ionized completely in solution. So they are all very weak acids. They show many properties of acids, but they are all weak acids. Okay. Now let us look at a few properties of carboxylic acids. Okay. So first, the methods of preparation. So how do you prepare acids? Methods of preparation. Now this part I can tell you is very easy. So you all will learn it easily and remember it also. So first method of preparation is from alcohols. Now you have learned how to prepare from alcohols. How do you prepare acids from alcohols? I told you, you should remember Aam Aadmi Party. From acid to that is from acid to alcohol, and Pa, it is from alcohol to acid. So how will I prepare from alcohol to acid? Primary alcohols. How do they give acids? Do you remember? How can I make acids from primary alcohols? By which method? By oxidation. And how? By using strong oxidizing agent like A2CR2O7 and H+. or alkaline KMNO4. Both of them can oxidize any primary alcohol to an acid with same number of carbon atoms. So supposing I take any alcohol RCH2OH, we have learned on oxidation it forms RCOOH. So supposing I take CH3, CH2OH, which acid will I get on oxidation? CH3COOH. This is ethanol. And the acid is ethanoic acid. So all primary alcohols on oxidation will give me on oxidation will give me carboxylic acids with same number of carbon atoms. If I start with aldehydes also, same way by oxidation, I will get carboxylic acid. So this is the most popular method from primary alcohols. You can by oxidation prepare carboxylic acid. The second method of preparation is this is for aromatic acids from alkyl benzene. Now here it is very important. I was telling you in the other case where I showed you how to prepare. You can take any carbon side chain. So if I take benzene and I have a side chain, and on the arrow I write KMNO4, alkaline KMNO4. Alkaline KMNO4, which is an oxidizing agent, especially for aromatic compounds. I will get CH3 will change into COOH. Now here very interesting thing is that if I have instead of CH3 anything which has a carbon side chain, like if I have CH2, CH3, this also on oxidation will give benzoic acid. If I have any other carbon side chain like CO, CH3, this also on oxidation will give me only benzoic acid, and all of them will require a carbon alkaline KMNO4. So any carbon side chain, if I have CHO, this is benzaldehyde. So obviously this also on oxidation will give me benzoic acid. So all compounds which have a carbon side chain will on oxidation give me benzoic acid. So that is the next method of preparation. The third method of preparation also I have taught you earlier, that is from cyanide. So I told you these are reactions which you have already learned, nothing new. So how do you get it from cyanides? I have already explained to you any cyanide. Supposing I take, say, RC triple bond N cyanide. When I add to it water, HOH, obviously in presence of H plus, addition of water will take place here. So what will I get? RC here OH and double bond NH. Okay, just adding water. So OH will go, negative part will go to the carbon, and see nitrogen is negative, carbon is positive, hydrogen is positive, oxygen is negative. So you know how the addition will take place. It is no big deal here. H will go here and OH will come here. Now what will happen is that this nitrogen has a lone pair of electrons. It will attract this hydrogen here. And the double bond will then shift here. Due to the rearrangement, you get RC double bond O and NH2. This compound, which has this functional group CONH2, is known as a amide. It is known as a amide. And this amide, if I again treat it with water, HOH, with water. So what will happen here? Again, nitrogen is negative, and carbon is positive. So where will OH go? OH will come here and H will come here. So what will I get? R, C double bond O and OH, and NH3 will become, NH2 will become NH. So if I take RCN and I write 2H2O, 2 times water, I can just replace CN with COOH. So this is from hydrolysis of cyanides. I have taught you earlier when we did alkyl halides also. I taught you cyanides are very important compounds. They can be changed. CN can be changed into COOH just by addition of water. Okay, so by hydrolysis of cyanide, wherever there is a CN, it is replaced by COOH. So supposing I have this compound CN, okay, cyanogen it is called. And I write here H2O and H plus on the arrow. This CN will change into COOH. And the other CN will also change into COOH. So what will I get? Oxalic acid. So without thinking, wherever there is CN, replace it by COOH by when we do hydrolysis. So it's a very important step in conversions. The fourth method of preparation, it comes from Grignard reagent. Now this one also you should now help me to do it. Grignard reagent. We have learned how to make aldehydes and alcohols using Grignard reagent, same technique. So I have to start with, I take the compound which is carbon dioxide and RMgX. So you know magnesium is positive, R is negative, oxygen is negative, carbon is positive. So where will R go? R will go to carbon and MgX will go to oxygen. So what will I get by addition? I will get R, C double bond O and here OMgX. And if I hydrolyze this product, I will get RC double bond OOH plus MgX OH. So basically, if I want to make, if I take C double bond O and C double bond O and I react it with CH3 MgBr, I can easily write the product in a single step also. How? The CH3 you have to attach here and to oxygen you always attach what? Hydrogen. So you will get CH3, C double bond O and OH. This is what? Acetic acid. This is acetic acid. So that is from Grignard reagent. The next method of preparation, shall I go further? The next method of preparation, before I do that, I want you to understand what are acid derivatives. Acid derivatives. What are acid derivatives? Compounds which are obtained from an acid. So what is my acid? R, C double bond O and OH. So what am I going to do? I am going to replace this OH with some other group to make it a acid derivative. So I can make 4 different acid derivatives. Okay, 4 different acid derivatives. What are they? This is 1, 2, 3, and 4. And in all of them, the common group is RCO, 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 C double bond O and R C double bond O. Let us spend some time here to understand their nomenclature and everything. Now, in the first case, what am I doing? I am replacing the OH with X. Okay. So what do I call this? I will call it acyl halide. We'll take example also. Second is I replace it with OR. Then this becomes an ester. Then the third is I replace it with NH2. It becomes a amide. And the third is I replace it with OCOR. This is anhydride. So I can obtain an ester, acyl halide, amide, and anhydride from where? From an acid by replacing the OH of the acid by some other group. So all these compounds, 4 of them are relatives of whom? The acid. Acyl halide, ester, amide, and anhydride. They are all obtained from acids. They can be obtained from acids. And all of them, when I hydrolyze them or I add water to any one of them, they change back to acids. So all these acid derivatives can be converted back to acid. How? By reacting it with water. If I react it with water or add water to any one of them, they will change back to acid. Okay, so this is preparation of acids from acid derivatives. So let me show you the reaction. This is known as hydrolysis of acid derivatives. So let me take different examples and explain this to you. So here the example that we will take is say CH3COCl. If I add to it HOH, what will happen? Cl will be replaced back by OH. So CH3COOH plus what? HCl. If I take CH3CONH2 and I add to it HOH, what will I get? CH3COOH plus NH3 backwards. Now, what is the problem in this reaction? The problem in this reaction is that this is an acid and this is a base. They will combine. And if they combine, what will they give you? CH3CONH4, a salt, ammonium acetate. To prevent that, we add an acid here. So if I add the acid, what will happen? Ammonia will change into NH4 plus, so that it is not able to react with the acid. If I take CH3, double bond O, OCOCH3, it is an anhydride of the acid. So if I add water, what will happen? Here OH and here H. So what will I get? 2 CH3COOH. So from an anhydride also I can get. If I take an ester, you know this reaction, esterification reaction we have already learned. So if I take an ester like this and I add water, what will I get? I'll get back CH3COOH and the alcohol CH3CH2OH. Okay, so all these methods are for the preparation of what? Acids from acid derivatives. So if I write a general reaction, all acid derivatives on hydrolysis can give me back the acids. We will also learn here in properties how you can make acid derivatives from the acid. And backwards also you know how to convert them. So these are methods of preparation of acids from acid derivatives. Now we will look at the properties of acids. Properties. Now, if I look at physical properties, the lower acids, no acid is a gas. So lower acids are liquids. Okay, lower acids are liquids. Some acids like oxalic acid, right? And benzoic acid. They are also solids. So it's not that all acids are liquids. Some acids are also solids like tartaric acid, citric acid, oxalic acid, benzoic acid. They are also solids. Why are they solids? Because they have extensive hydrogen bonding, right? So CH3, C double bond O and OH. And I take another molecule CH3, C double bond O and OH. Right? So hydrogen bonding is present here and also here. At two places, the molecules are held together by hydrogen bond. And so in solution, they may exist like dimers. You remember when we did oxalic acid in solutions, you realize that the colligative property here is half than the expected colligative property because they associate the molecules of water molecules, molecules of acids, they associate. Okay, so that is why they are um, existing because of hydrogen bonding. They literally exist as dimers. Then the second thing is they are the lower acids are water soluble. Whenever something, any organic compound is water soluble, again it is due to hydrogen bonding. It forms hydrogen bonds with water. So this is a little bit about acids. If I take benzoic acid, it is insoluble in water, insoluble in cold water. But it dissolves in hot water. Dissolves in hot water. Why the solubility is less in cold water? Because of the benzene ring, which is hydrophobic. It prevents solubility, but at higher temperature, because of hydrogen bonding, it forms, it dissolves in water. Now the chemical properties. So chemical properties, first is acidic nature. Okay, what is the acidic nature here? What do you understand by acidic nature? They all give H plus easily when reacted with active metals. So there are three reactions which show they are acidic in nature. First is any acid, RCOOH plus Na. It forms salt and hydrogen. Which salt? RCOONA plus half H2. So this formation of this hydrogen shows that there is an acidic hydrogen. This is the sodium salt of the acid. These acids also react with sodium carbonate, right? To give you RCOONA plus CO2 plus H2O. Like any other acids, they react with carbonates. And acids also react with NaOH, alkalis, to form salt and water, RCOONA plus H2O. So they are all more acidic. Remember, acids are more acidic than phenols, and phenols are more acidic than alcohols. Okay, phenols are more acidic than alcohols. The most acidic is, the acidic nature is maximum in carboxylic acid. They are weak, but they are stronger acids than phenol. Okay, why? Due to stability of carboxylate ion. Carboxylate ion. Carboxylate ion stabilizes highly by resonance. Carboxylate ion is more stable than phenoxide ion. So carboxylic acids are highly acidic. Now again, like phenols, we have to see the effect of substituents on the acidic nature. Effect of substituents on the acidic nature. So let us see what happens when I add a substituent on the benzene ring or on the carbon. Say for example, CH3 COOH. I need to compare it with Cl CH2 COOH. Which is more acidic? Can you tell me? Any one of you, which is more acidic? Who will tell me?
The CH3COOH.
This one is more acidic, right? Why? Because of the minus I effect of Cl. Okay, so it pulls electrons, so it helps. Oxygen is pulling in this direction, chlorine also in the same direction. The two pulls in the same direction, the carbon of this bond becomes more polar, and so this is more acidic. Supposing I have to compare Cl CH2 COOH with F CH2 COOH, which will be more acidic? This is more acidic. Why? Because minus I of F is greater than minus I of Cl. These are the give reason questions. Why? Right? So any electron withdrawing group increases the acidic nature, and electron pumping group, it decreases the acidic nature. It decreases the acidic nature. Now, supposing I have to compare it with if I have Cl and CH, Cl, COOH, and Cl, CH2, COOH, 2Cl. Obviously, the first one is more acidic. Why? Because minus I of 2Cl groups, okay, is greater than minus I of 1Cl. So there are a lot of questions which are asked here because of comparing the acidic nature. Now, supposing I have to compare the acidic nature of next HCOOH and CH3COOH. Now, the CH3 group has what? Plus I effect. Plus I in this direction. Oxygen is pulling in opposite direction. So this becomes weaker. Formic acid or methanoic acid is stronger than ethanoic acid. As the carbon chain increases, the the acidic nature decreases. So this, if I take another acid CH3, CH2, COOH. So this will be even weaker because here there is a larger plus I effect of ethyl is greater than plus I effect of methyl. So like that, there can be several comparisons. Now, supposing I have to look at benzoic acid, C6H5COOH, and I have to compare it with CH3COOH, right? Here, we have to look at the stability of the carboxylate ion. So whenever there is a benzene ring, there is extra stability. Why? Because of resonance. So this will be more acidic than acetic acid. Benzoic acid is more acidic than acetic acid. So these are different reasons. Now, if I take benzoic acid and I put something on the benzene ring, right? All of you look at it and answer me. Who will tell me the correct answer? We have done the same with phenol. It is the same with oxalic acid. There is an electron pumping group, EPG. Here CH3 is a EPG, and I put a NO2, which is EWG. So this is pulling in this direction, this is pumping in the. So EPG, what does it do? And EWG, what does it do? So which is the strongest here? Who will tell me? Which is the strongest here? Sai Kalyan, which is the strongest? Hariharan, today you haven't opened your mouth. Tell me.
Ma'am, the most acidic is NO2, ma'am.
Yes, this is
Meta.
the most, yeah. This one will be the most acidic. Para nitro benzoic acid will be the most acidic. Why? Because NO2 has a
Electron withdrawing group, ma'am.
So any electron withdrawing group makes the substituent and makes the acid more acid. Okay. So that is preparation of the acidic nature. Now let us look at the other properties. First, the second property that I have to understand is preparation of acid derivation of acid derivatives. Okay, so we have to look at various, we already know what the acid derivatives are. Now, how from the acid I will make the acid derivative. So supposing I have CH3COOH and I want to convert it into CH3COCl, right? How will I do that? I can make use of PCl5. I don't know what does PCl5 do. It removes the OH and replaces the OH with Cl. The same thing it was doing to alcohols. So what will I get? CH3COCl plus POCl3 plus HCl. I can use instead of PCl5, I can use PCl3 or SOCl2. I'll get the same product. I can write here CH3COOH plus SOCl2. I can get CH3COCl plus SO2 plus HCl. Just like acids, only OH is being replaced by Cl. Same way, just like alcohols. So that is preparation of acyl halide. So if I want to replace OH with any halide, I have to react it with PCl5 or PBr5 or SOCl2 or SOBr2, depending on what I want to put here. So this is A. If I want to make an ester, what will I do? CH3COOH and react it with an alcohol. This is again you have learned along with alcohols, right? In presence of H plus, this is a reversible reaction. You will get an ester, CH3COO, C2H5 plus H2. This is esterification reaction. What is the name of this ester? Ethyl ethanoate, if you remember. Ethyl ethanoate, right? That is the ester that you prepare. The third is to make the C, the third one is you take an acid CH3COOH and you react it with ammonia, NH3. So what will you first get? CH3COONH4, which is ammonium acetate. Ammonium acetate. Now this ammonium acetate, if I heat it, water will be eliminated and it will change into an amide. What do I call this? Ethanamide. Or common name is acetamide. And the last one is to prepare an anhydride. The fourth one is to prepare an anhydride. So anhydride, before I do anhydride, there is one more which is reaction with ammonia. Like for example, if I have the benzene ring, COOH and COOH, I get a very interesting compound with ammonia. I write ammonia like this, NH3, right? N and 3 hydrogens. So this will react, water will be, this will react, water will be eliminated. And what will I get? Benzene ring, CO, CO and NH. This is a special amide. This is also amide, but a special amide. So you call this phthalimide. Okay. Remember this compound phthalimide, we will need it in compounds containing nitrogen. The last one is the last reaction for the preparation of anhydride. So CH3COOH and CH3COOH. I reacted with P2O5. P2O5 is dehydrating agent. So what is it? Water will be removed. So H from here and OH from here. I remove water. So what will be left? CH3CO and here CH3CO connected by O. This is what I wrote in a straight line, CH3CO and OCOCH3. This is acetic anhydride. Why do I call it acetic anhydride? From acetic acid, I have removed water. So it has become acetic anhydride. So you can make all acid derivatives starting from an acid. So that is one part of the properties. And all the acid derivatives can be converted back to acid by just adding water. So forward and backward, both reactions you should remember. Now the next is reduction of acids. Now reduction also you have learned. If I reduce an acid, there's only one reducing agent, RCOOH, backwards, right? Aam Aadmi Party. Acid to primary alcohol. It will become RCH2OH. And what will I need? The reducing agent, lithium aluminium hydride. Lithium aluminium hydride. So if I use lithium aluminium hydride, acid will change into alcohol. Then the next reaction is known as decarboxylation. Decarboxylation means what? Removing the COOH from the acid. If I remove the COOH from the acid, what will I get? So supposing I have CH3, CH2, COOH, right? By decarboxylation, I will remove the COO and it will become CH3, CH3. What did I remove? COO. If I have CH3, CH3, CH, and here COOH. If I do decarboxylation, what will I get? CH3, CH2, CH3. So this is the method by which we literally remove what? COO. That is why we call it decarboxylation reaction. So how do you do decarboxylation? It is done with soda lime. Soda lime and dry distillation. You heat it with soda lime. What is soda lime? NaOH and CaO. If you remember, we learned this reaction in preparation of methane. From acetic acid, you can prepare methane. So this is a reaction known as decarboxylation reaction. From the acid, directly you get an alkane, which will have one carbon atom less than the acid. One carbon atom less than the acid. Okay. Now we are almost finishing it. Decarboxylation. Now we come to the very important reaction. I will write the name in this in red so that you remember that it is an important reaction. It is known as HVZ reaction. HVZ stands for Hell-Volhard-Zelensky's reaction. Hell-Volhard-Zelensky's reaction. Now this reaction is known as known for what? Alpha substitution. So obviously the acids which have alpha hydrogen only can show this acid. What is alpha hydrogen? In CH3COOH, what is alpha hydrogen? Hydrogen which is directly attached to alpha carbon, right? So if what is alpha carbon? Directly attached to the functional group. So COOH, this is the functional group, this is alpha. Supposing I have CH3, CH2, COOH. This is functional group, this is alpha, this is beta. So this one is alpha hydrogen. So this reaction is shown where substitution happens at alpha carbon or alpha hydrogen is substituted. So how do you do this reaction? For this reaction, you react your compound with a halogen, say for example, chlorine, in presence of red phosphorus. In presence of red phosphorus. So what happens? Alpha hydrogen is substituted. So you will get CH3. Instead of CH3, it will become CH2. One hydrogen will be substituted. CH2Cl and COOH. If I continue the reaction with chlorine and red phosphorus, more hydrogens will be substituted. So I can get CH, Cl2, COOH. It will still continue, chlorine and red phosphorus. What will I get? CCl3, COOH. So how is the question asked? What happens when acetic acid reacts with chlorine in presence of red phosphorus? What are the products obtained and which of the acids formed is more acidic? So you will get chloroacetic acid, dichloroacetic acid, trichloroacetic acid, and which will be most acidic? Trichloroacetic acid, because of the minus I effect of 3 chlorine atoms. So this is Helmholtz-Zielinski's reaction. Now supposing my second acid was there, CH3, CH2, COOH, and I had reacted it with chlorine in red phosphorus. What will I get? CH3, CHCl, COOH. This hydrogen will be, this is the alpha hydrogen which will be substituted. Okay, so you have to make sure that there is alpha hydrogen. Supposing my acid is this CH3, COOH, and I reacted with chlorine, right? There will be no reaction. Why no reaction? Because there is no alpha hydrogen. Which is alpha carbon? This is alpha carbon. There is alpha carbon, but it has no alpha hydrogen. Benzoic acid, C6H5, COOH, right? There is alpha carbon, but there is no alpha hydrogen. So this also will not show HVZ reaction. So HV reaction is shown only by those acids which have alpha hydrogen. So this is known as alpha substitution. Now the last reaction. The last reaction is reaction with reactions due to benzene ring. Reactions due to benzene ring. So here again you have to remember COOH group is what? COOH is meta-directing and deactivating. So since it is meta-directing and deactivating, only halogenation and sulfur and nitration. So these are the two reactions. If it is benzoic acid, you know I can write two reactions, bromine and FeBr3. I will get meta-bromo-benzoic acid, COH and Br. And if I do nitration, HNO3 and H2SO4, I will get meta-nitro-benzoic acid. So we are done with carboxylic acids also. Now we will do a few tests for carboxylic acid tests. How will you identify? First is for acetic acid or ethanoic acid, or acetic acid. How will you distinguish it? With ferric chloride, FeCl3. It gives wine red color. You have learned the test for acetate. Have you done some salt analysis in the lab?
Yes, ma'am.
Yes, ma'am.
So have you done the test for acetate ion with neutral ferric chloride? This is
Not
neutral
yet, ma'am.
ferric. So when you do test with neutral ferric chloride, you will get a wine red color. That is a test for acetate ion, also for acetic acid. The test for benzoic acid. Benzoic acid, how will you do? With neutral ferric chloride. Ferric chloride, which is neutral. What will you get? You get a buff PPT. Buff means flesh colored precipitate. So ferric chloride gives a wine red color with neutral ferric with ethanoic acid, and it gives a buff precipitate with benzoic acid. One other compound can be distinguished here. It is phenol. Phenol gives which? Violet color with phenol. So neutral ferric chloride gives violet color with phenol, and wine red with acetic acid, and buff precipitate with benzoic acid. So it's a good reagent. You can distinguish many things from it. Then there is formic acid or methanoic acid. Methanoic acid. Methanoic acid is very interesting. It can be distinguished because it forms a silver with Tollens reagent. It's the only acid with Tollens reagent. It gives a silver mirror test. Silver mirror, just like aldehydes. It gives a silver mirror test. Why does it give a silver mirror test? Because if I write the structure of formaldehyde, it almost acts like aldehydes. Why? Because it has a CHO group. So the acid which acts like aldehydes is which one? Methanoic acid. Okay, so this was for aldehydes. Now I need to, in the one more class I will devote to this chapter in doing all the questions from the textbook. So we'll practice all the questions in the next class. Before I close, let me show you two important conversions. One is stepping up. So that means CH3COOH. I want you to convert it to CH3CH2COOH. That means ethanoic acid to propanoic acid. Ethanoic to propanoic acid. Stepping up. So you should remember these few things. How will I do? I need to, if I want to step up, I need to reach a cyanide. For reaching a cyanide, I need to reach a halide. For reaching a halide, I need to reach an alcohol. So from an acid, how do I prepare alcohol? First, lithium, aluminum hydride. So which alcohol will I get? CH3CH2OH. Now you know PCl5. What will it give? CH3CH2Cl. Now what will I do? NaCl. CH3CH2Cl. And now H2O and H plus. Cn will change into COO. So this is stepping up, backbone for stepping up. Convert it into alcohol, alkyl halide, then cyanide, and then COOH. What did I do? I have used all the three chapters: alkyl halides, alcohols, and aldehydes and acids. Everything I have put them together to get this. So in organic chemistry, what happens? It is not like learning electrochemistry and kinetics and solutions separately. They are all combined. They are all combined together. So one to the other, you have to know the link, and you should be able to do all of them. So the secret of doing well is you have to revise everything and try to look at the big, it's a huge exercise which has about 50 questions in that exercise. Be prepared. We will practice it in the next class. Now we have to finish our syllabus by October, by September end, sort of October. So that is, I have to go at a little fast speed. Organic, lot of it is over now. Major organic is over. Only 2 chapters are remaining. Physical is one, which is kinetics. Now, can you tell me, you want to start with kinetics or shall I start with D block elements? What should I start with? Or coordinate kinetics? Chemical kinetics. So in the next class, we will start with chemical kinetics. I will see if I can have one more class on this organic. I would rather do that, but if not possible, I will start chemical kinetics. Okay. So see you all. Thank you very much for staying through the class today. There was good attendance, all of you. And especially Vaishnavi for keeping your camera on. Even if one person keeps the camera on, I'm motivated to teach. So thank you so much. And Deepak and Adok Shajan, please go through the previous videos and please talk to the manager to understand if you need an extra class. I can arrange an extra class maybe on Saturday or Sunday, but that you have to talk to them. Okay. So see you in the next class. Bye tomorrow. Bye.
Thank you, ma'am.
Bye. Thank you.
Thank you.
Thank you, ma'am.